Um, Hi, my name is Bhagwan Nayak Megawat, and now my matriculation number is like 33442631. Now I'm presenting my deep learning model, and the project name was like wildfire detection using satellite images with EffecientNet V2S. Basically, I choose this project because the wildfires are becoming more frequent due to climate changes, human negligence, and deforestation. Early detection is critical, but traditional methods like ground sensors or manual monitoring are slow and not stable. So I set out to build a machine learning model that could automatically detect wildfire scenes from satellite images. This model is fast and accurate with minimal complexity. The reason behind I'm choosing efficient V2 net V2 efficient net V2S is it's lightweight and fast with a ideal which is ideal for real time use. It was trained on ImageNets and understands general visual patterns, which is perfect for my wildfire classification. And I choose the data set from wildfire, a open data set like public data set from the Kaggle, and it was like wildfire detection image data set, and it has two classes like fire and no fire. The fire, it has the testing data, training and validation in a ratio of like 80 is to 20. Training and validation has 80% of the images, and testing has the 20% of the images. And I imported like you can see here. See, I loaded the data path. It has a total of 1900 images approx, and here we can see there are the two classes. And as the down we go, I trained my model for the 20 epoch, which is like 20 is the ideal number. The model won't be trained, it won't be overtrained, and it won't be less trained. So here we can see the training losses are minimal, like 0.0086, like nearly 1%, and training accuracy is also high. Validation accuracy is also like 96.72, and the best one was 97.56. It was noted down every time for each epoch. When it trains, it chooses the best value. If the value is best, it takes the best, or else it will go to the next epoch. And here after training, I have done like it's like 97.54% validation accuracy, and I plotted this on a graph. Here below we can see the validation and like training versus validation accuracy. The training was like around 97, and the accuracy, like validation accuracy, is also around 97.54. The losses are very less, like you can see the curve fluctuates between 0.08, like 1% approx 1%. So, and here we can see the test accuracy is 92.65%, which is good. So as it's greater than 90%, so we don't need to use fine tuning, because tuning is not needed, as it all as it is performing greater than 90%. So as we go down here, I have the classification report of my trained model, and I have even from the dataset I have given training, validation, and testing images. It has predicted like the fire precision for the fire was 0.87, like 87%. For recall, it was like 91%. And F1 score is the mean of the precision on recall. So it can be said as like higher the F1 score, the better the model performs. mm, the better the model performs. So it goes like that. You can see like total 22 test images, and for no fire it was like 46 test images. And I do have the confusion matrix of the test dataset, and it predicted good. Like actual fire was 20, and prediction is also 20. So it misled 2 as the no fire, and actual no fire was like out of 46 images, it predicted no fire as 43 and fire as 3. Like it was a small margin, and it was considerable because we are training this model. And so after training, I need to test it on the data set. So I initially did it on my own data set, like Kaggle data set, which I have been training my model. So first, I have generated heat images for the my data set, and it was given like for the no fire, actual no fire, it predicted like no fire. So it was right. And for prediction fire and actual is also fire. So I have given like this 5 images for testing, and it's here like predicted no fire, and it is also no fire with 100% accuracy because it was trained already on this data. And drop down, like we can see predicted no fire, actual is also no fire. Down also predicted no fire, actual is also no fire. So now I wanted to test this model based upon the Google images, which I have never trained it. So I downloaded Google images and I converted in the JPEG format, and I made my own data set, and I named it as Wildfire sample, and fire and no fire, two classes I have given it. And you can see the images like down. See here the it is a fire image. So and I have run it through, and it gave me like, see, actual was fire, and it was predicted as fire, 74% with accuracy. And down we can go like some. There are few wrong predictions also. Here you can see predicted no fire and actual is also no fire. Here predicted fire, actual is also fire. So there are few wrong predictions. You can see like here predicted no fire and actual was fire. And down also here no fire and actual was fire. This might happen because of some fire images were predicted as no fire because early stage fires and thin smoke are often usually not visible that much, and it might think as a cloud sometimes, floating cloud. So this model ignores those things. Yeah, we can see that. And with this, I am concluding these topics, and I need to address few questions. And it has the validation and test accuracy. Like validation accuracy is 97%, and test accuracy is 92%. It generalizes the unseen data, and it has the high test performance. There is no need of the complex detection. The simple classification pipeline is good enough for this, and the accuracy and efficiency are both good for EffecientNet V2S model. And absolutely without fine tuning, it works good. So we can develop this model for the satellite image wildfire detection, and it will be very helpful to in the early detection, at the early detection of the fires. Because of like why in traditional methods it's gonna take a lot of time, and sometimes it will be too late before detection. So by this we can say that it model helps in detecting wildfire detection easily. Thank you.